So here is a video expanding upon the video that you saw previously dealing with solving linear equations algebraically. This is solving some of the same linear equations that were solved in the previous video, but using a graphical approach. So we're going to jump right into the example. Example 1. You have 7x minus 1 equals 2 plus 3x, right? So we have on the left side this 7x minus 1, that's the equation of a line. And on the right side, we have 2 plus 3x. That's also the equation of a line. So what we're going to be doing is graphing both of these lines, and we're going to be looking for where they intersect, because that intersection point, the x value on it, represents the solution to this equation. So I'm going to go ahead and go to y equals, and I'm going to clear out any equations that I have. And I'm going to go ahead and type in on the left side, whatever is to the left of the equal sign, I'm going to put there. So I'm going to put 7x minus 1, right? Go down to the second equation, y2, and I'm going to type in 2 plus 3x. And I'm going to go ahead and I'm going to graph these lines. And so here my window settings are kind of messed up. So if you're not sure, you can always press zoom and go back to the option 6, the standard window setting. That'll give you your standard viewing window from -10 to +10 on both the x and y axis. And so here I can clearly see the intersection point is somewhere here. You always want to make sure when you're solving these equations and you're using the intersection method, you want to make sure that you can see the intersection method in the viewing window. And in this case, we can. So there's no need to adjust the window settings. So press second, trace, go down to option 5, the intersect, or press number 5. And then the cursor is going to go to the first curve you typed in, 7x minus 1. So you want to be pretty close to the intersection point. So only use the left or right arrows to go close to the intersection point. So here we probably don't need to move it because it's already pretty close. So I'm just going to go ahead and press enter. It's going to jump to the second curve that you typed in, 2 plus 3x. It's already pretty close to the intersection point, so I'm just going to press enter again, and then press enter one more time. And so we see the x value here is 0.75, right? So x equals 0.75. That is our solution, but a lot of times they're going to want it as a fraction, not a decimal. Depends on the problem, so x equals 3/4. Okay, so we've solved this equation graphically. Let's look at example 2. We have here x minus 7 over 8 equals 4x plus 1/2. So the same approach, I'm going to go to my graphing calculator, and on the first y sub 1, I'm going to type in whatever I see on the left. So that's x minus 7 divided by 8. Go down to the second, y sub 2, I'm going to type in whatever's on the right, so that's 4x plus 1 divided by 2. And I'm going to go ahead and graph both of these lines. Once again, we don't have to do much work here. The intersection point is somewhere here, so now we just need to find that. It's already on the viewing window, so no need to adjust the settings. You press second, trace. To calculate the intersect, you go down to the option 5, press enter, and then you want to guess, right? You're going to end up pressing enter 3 times. It's going to go to the first curve, and it's already very close to the intersection point, so just press enter. It's going to jump over to the second curve, once again, very close to the intersection point, so just press enter and press enter again. And so you end up with x equals negative 45833 repeating. Okay, well, the a lot of times my math lab will not accept that, so you need the fraction form. So I'm going to go ahead and get out of that. And if you go here, you can type in this decimal and put in a bunch of 3s. Put in enough to where you're sure it's going to actually convert it to fraction correctly. So I just put in a bunch of 3s since it's repeating, and I'm going to press enter. And then you go over to math and you want to convert to a fraction. So just press the first option, number 1, just press enter and then enter again. And so this number in fraction form is a negative 11 over 24. So that's our answer. Okay. The next example, we have 0.3x minus 0.2 equals 2.4. So this is another linear equation. So I'm going to go ahead and graph what I see on the left side of the equal sign. So 0.3x minus 0.2. And on the right side, I'm going to go and graph the 2.4. The 2.4, notice it doesn't have an x, so this is actually a horizontal line, right? The 2.4 is just a constant. And so we're going to go ahead and graph it. And once again, we could see it on the standard viewing window. When the intersection point is on the standard viewing window, it's pretty straightforward. You don't have to do much work. So press second, trace. We want to calculate the intersection point. So I'm going to go ahead and move my cursor to the right a little bit closer to that intersection point. Doesn't have to be exactly on it, just a little bit closer. Press enter, and we jumped up to the second curve. It's pretty close, so I'm going to leave it right there. Press enter, and then I'm going to press enter one more time. And so we end up with x equals 8.66 repeating. Once again, my math lab is going to probably want that in fraction form. So we go to 8.66. So if you only type in that many sixes, it may not work. You want to type in enough to where it actually converts it. Press enter. Then go to math. The first option converts to a fraction. And then press enter again. And you end up with x equals 26 over 3. Okay. So example 4. Here we have 5 times x minus 5 divided by 6 minus x on the left side. That equals 1 minus x over 9. So we're going to use the same approach. So clearing out y sub 1, we're going to put in what's on the left side. And then divided by 6 minus x. Now on the right side, we see 1 minus x over 9, so that's x divided by 9. And we graph it. Okay, here, these are the ones that can be a little more challenging with a graphical approach. They take a little bit of trial and error on this part because you have to see the intersection point. And here we don't see the lines intersecting. They almost kind of look parallel, but they're not quite. They look like they're getting a little closer over here on the left side of the calculator, right? So what that's telling me is that I may need to extend my x-axis a little bit more this way to try to capture that intersection point. So this is just trial and error. So the x-axis now runs from -10 to 10. So I'm just going to do, let's say, -150, just to be safe. Let's go out a little bit further. I'm going to leave my x max right there. Since I scaled, since I went all the way down to -150, I'm just going to bump this up a little bit. Let's say 20. Okay, and I'm going to leave the y-axis alone for now. Let's graph it and see what we see. Well, we didn't go up quite far enough with the y-axis because see, here's the intersection point. You see the lines are getting closer together. So I'm going to go here to my window settings, and I'm going to bump up my y-axis a little bit. And I'm going to just go up to, let's say, 50. Try that. See if that works. And there we go. We can now see the intersection point. That was just trial and error and me using where the graph is kind of going as a guide. And so now I'm going to press second, trace. I'm going to press number 5, and I'm going to calculate the intersection point. So you press enter, first curve, second curve, and then guess, enter again. And so here our solution is, it has to say intersection here, x equals negative 93. Okay, so last example. A building worth $833,000 is depreciated for tax purposes by its owner using the straight line depreciation method. The value of the building y after x months of use is given by the equation y equals 833,000 minus 2,200 times x, where y is the value of the building. After how many years will the value of the building be $648,200? Okay, so our equation here, y equals 833,000 minus 2,200 times x. When I'm doing applications, I always like to write down what x and y mean. Y is the value of the building in dollars. X is the amount of time in months. We want to know after how long or after how many years will the value be $648,200. So that is y, the value of the building. So I'm going to replace y with $648,200. Okay, so now I need to go over. So y1, I put the 648,200 on y1, and y2 I put the right side. This should be at a 0 here. I put this under y2 and that under y1. So we're going to go ahead and graph them. Okay, you're not going to see anything here because this number is so large. It's almost 650,000. That means that's a horizontal line. So that means that y-axis is going to have to be adjusted to include at least 648,000. So I'm going to go a little bit higher than that. And like I said, this is the trial and error part. This is really the hardest part of the intersection method. So I'm going to leave my x value negative 150 to 150. And I'm just making up these numbers. I'm trying something out. I'm going to change my x scale to, let's just say 50. My y min I'll put at, let's say 200,000. And then my y max has to include the 648,000. So I'm going to go up to 675,000. And then since my scale is so large, I'm going to bump this up to like 10,000. And I'm going to go ahead and graph it and see if I can see the intersection point. And I can. Okay, so I'm going to press second, trace, and I'm going to go down to option 5. First curve is the horizontal line. I'm going to move my cursor over a little closer to that intersection point just to be safe. Press enter. The second curve is pretty close to the intersection point. I press enter and press enter again. So 84, right? X is 84. But remember, we're talking about months here. The question asks for years, okay? So you basically have to convert the months to years. There's 12 months in a year, so you divide by 12. And so that's going to tell us that the value of the building was originally $833,000. But after 7 years, the value of the building is going to depreciate to $648,200. So your answer here would be after 7 years.